we were exposed to a geometric sequence before, and the question is, if we look at a series associated to a geometric sequence, can we find its sum, assuming that it's finite? So we're going to work under that premise of working with a finite geometric series. So let's take a look. So if I look at S sub n, this is equal to a1 plus, and this would be a1 times r plus a1 times r squared plus so on and so forth, and the nth term would be a1 r to the n minus 1, right? Okay, now as it happens, we'd want to look at r s sub n, so multiply this equation on both sides by r, so we have a1r plus a1r squared plus a1r cubed plus so on and so forth up to a1r to the n, and let's take their difference and see what we get. Okay, so I have s sub n minus r s sub n. Okay, so this is going to be, okay, so let's see, I'd have a1, right? And then this term and that term would cancel. That one and that one would cancel. This one and the next one would cancel. And this would actually cancel with the term right before. So all I'm left with is plus a1 r to the n. Okay, and now my ultimate goal is to solve for s sub n, right? So I need to isolate that. Algebraically, I can factor it out, 1 minus r. And then on the right side, I can also factor out the a1 just because it's a common factor. And I'd be left with 1 plus r to the n. And then divide by Sn. And I get the sum of a finite geometric series of the first n terms. Except I messed up a sign. This should be a minus. And this should be a minus in here as well. Okay, so there, that matches the formula that's down below. Okay, so if we're summing the first n terms of a geometric series, this is the formula we can use. Take the first term, multiply by 1 minus r to the n over 1 minus r. This is actually super nice because you only need to know 3 things, which are relatively easy to find. You need to know the first term, you need to know the common ratio, and you need to know the number of terms you're adding. That's all you need to know. You don't need to know the nth term. Okay, so then if we look at applying this to an example, right? I can say, okay, the sum of this is from the first term to the 7th term. This is going to equal, okay, this would be a1 times 1 minus r to the n, so 7, all over 1 minus r. Okay, so now I need to go through and identify the pieces. Well, this is like a1 r to the n minus 1, right? So that means a1 is 9, r is 1/3, and I think that's all I need to know, okay, because I know the rest. So then I have 9 times 1 minus 1/3 to the 7th power, all over 1 minus 1/3. And now this is where we take our calculator and substitute this stuff in very carefully, and we get 1093. I did this as a fraction, so it'd be 1093 over 81. If you did it as a decimal approximation, accurate to say, oh, I don't know, 2 decimal places, it'd be about 13.49. Okay? So that was fun. Let's do another example. Okay, find the sum of the finite geometric series. Well, so the beauty about all this is that you need to know, oh, okay, what do we need to know here? We need to know n, right? I know what a1 is. a1 is 3. And then 1 minus common ratio, which appears to be, let's see, between there and there, it's times 2 times 2. So it'd be 2 to whatever n is, right? All over 1 minus 2. Okay, so I just need to figure out 768 is 3 times 2 to the nth power, or to n minus 1 power, right? So, okay, let's divide that by 3. That's valid. So 768 divided by 3. On my calculator is 256. 2 to the n minus 1. And so now this is where we need to solve the exponential equation. You may need to unearth some of those skills or go through your powers of 2. 2 to the 9th, actually 2 to the 8th, I'm sorry. 2 to the 8th is the same as 256, okay? And since the bases are the same here, you can drop them and just say 8 is equal to n minus 1, or n is 9. So then that allows me to say, okay, this is the sum of the first 9 terms. That's a 9. And now I can go forward and do the calculation. And I got 1533, okay? So let's review what we did in this one, okay? I know I need a sum of finite geometric series, which its formula is s sub n is equal to a1, 1 minus r to the n over 1 minus r, okay? Based on the progression here, I was able to say, okay, a1 is 3, first term, and then my common ratio here appears to be multiplying by 2, so r is 2, substitute that in, but the only thing that I didn't know was what n was, like how many terms I'm adding. Now I could go through and try this out, like do 3 times 2, okay, get 6, and then just continue to multiply by 2 to get 768, and just calculate that out, but I preferred to use the formula where I have like an is equal to a sub 1 r to the n minus 1, and use that. It's a little bit prettier, but it's effectively will give you the same answer as if you were just to count. And so I did that. I said 768 is equal to 3 times 2 to the n minus 1, and solved the resulting exponential equation for n. Found that n was 9, substituted that back in to find s sub 9, and I'd be done. Okay, so for a finite geometric series, we can use this formula. Just make sure that you have all the pieces before you move on.